In this assignment, we're supposed to find the characters that occur exactly once in a string. For example, the letter M here doesn't occur anywhere else, so we're supposed to report it. So let's see how we're going to do this. Clearly it makes sense to go through the string a character at a time. So for each of the index positions, we want to look at the character and then do something. So let's look at the M. And what's the logic here? Well, we look at the tail, everything else, there's no M here, and therefore we're justified in saying the M is unique. So if we keep track of the unique ones, we stick the M on there. And that strategy works great. Now when we look at the I, for example, and then we look at the rest, we see that the I occurs elsewhere, and so the I is not unique. So we'll move on and have a look at the S. And by the same logic, since the S occurs in the tail here, the S is not unique. But now we're running into trouble. Now we move on to the next character. That's the S again. And now if we look at the tail here, then it doesn't occur here. So we would be tempted to say that the S should be added to the unique characters, but clearly it shouldn't because we've just seen an S. There are various ways of solving that problem. One simple way would be to look to the left and to the right. Another slightly more efficient way, and that's the way that I'm going to show you in my solution, is to keep track of two sets of characters, the unique characters and the ones that we know to be duplicates. So if we keep the duplicate characters, we also keep them in a string, then we would have added the I to it as soon as we knew that the I was duplicate. We would have added the S to it as soon as we knew that the S was duplicate. And then when we see the second S here, now we're going to look at two places. We're going to be looking at here, like I already said, and we're also going to be looking into the duplicate string. There we're going to find the S, and therefore we're going to not include the S in the result. Moving on to the O, that's not contained in the duplicate string here. It's not contained in this substring here. So it gets added here. And the same is going to be true for the U and the R. And then when we see the I here, then that one is again a part of the duplicate string, and so we're not reporting it. And the result that we're getting is these four characters, which is exactly what we're supposed to be getting. So that's the idea. Look at all of the characters in the string, keep track of both the unique and the duplicate ones. So here in the code, the unique ones here are called result. Whenever I can't think of a good name and it's the value that I'm returning, I just call it result. Here's the duplicate. Now I'm iterating through all of the characters in a string. There are any number of ways of doing this, but this is by far the most common. So I'm letting I go from 0 to the length of the word, and then I'm extracting the ith character. And I like to extract it as a string, unless there's a really good reason to extract it as a char value, which I don't think we're going to see in this course. So now I'm checking whether this string is already known as a duplicate, because if it is, then there's no point in even looking at it any further. Now I'll check, does it occur in the tail? And here I'm using the index of method because it nicely lets me put the starting index of the search. Whereas with the contains method, I would first have to make a substring and then throw it away again. So this is just slightly more efficient. Don't worry if you use substring and contains, that's just fine. You could also have used a second nested loop, but that's clearly more work. So here we're checking whether the ch is contained in the tail, and if it is, we say, oh, it's a duplicate. And if it's not, then it's added to the result. and in the end we print the result. And that's all there's to it. So what made it work? I've seen quite a few frustrated attempts about this at Piazza, and really the key is to first get out a sheet of paper and to come up with a scheme that really works. What generally does not work in this situation is to take a bunch of half-working loops and try to beat them into submission. That really is a difficult task. If you have a clear idea that's logically clean, that's the way to do it.